저희 영업을 해오는 FPGA 패브릭이 들어있고, 그 다음에 왼쪽 밑에 보시면 암 부분이 이제 프로세서 부분이 되고, 그 외에도 이 5G를 도입하고 전개하기 위해서 필요한 다양한 기능들이 이런 하나의 형태로 들어가게 되고요. 이렇게 되면은 아날로그하고 프로그래머빌리티뿐만 아니라 지금은 그 프로그램 할 수 없는 RF 분야, 아날로그 분야에까지도 이런 프로그래머빌리티를 도입할 수 있다는 얘기가 됩니다. 아날로그 부분의 프로그래머빌리티를 도입을 하고, 그래서 아날로그하고 디지털 부분을 합치게 되면은 결국 50에서 70%까지의 전력 및 풋프린트의 감소를 가져올 수 있다라고 저희가 얘기를 하고 있는데요. 그럼 지금부터는 과연 어떻게 이런 감소가 일어날 수 있는지에 대해서 설명을 드리도록 하겠습니다.
Thank you, Tim. So I'll reiterate what Tim just mentioned. Power is very important because we need to achieve energy efficiency. Form factor or footprint is very important because we want 5G massive MIMO to be compact so that we can do dense deployment. Design cycle efficiency is very important along with programmability because we want our customers to build flexible, scalable systems where they can innovate and differentiate during the life cycle of the equipment. To understand how we achieve these three goals, let's look at a radio design as it exists today. This is a conceptual diagram where on the left-hand side you have the digital part of the radio, and on the right-hand side you have the analog portion of the radio design. So in this diagram, if you see the analog components, which are A to D converter and D to A converters, they are connected to the digital portion using high-speed transceivers or high-speed I/O links. In this diagram, we are showing just two paths, two transmit paths and two receive paths, which will correspond to a simple 2x2 radio equipment. And if you look at the power consumption, typical power consumption, it's significant because of the interface that these devices need to carry. So as we talk about 5G now, the number of chains, number of transmit and receive paths will increase tremendously to support massive MIMO. Therefore, the power will go up significantly in bringing the interface between digital and analog components within the radio. So how do we solve this? The solution resides in bringing the analog components and integrating these components along with the digital part of the radio. So this solution, key benefit, integration gives power and footprint reduction. Programmability gives us scalability and flexibility while allowing our customers to innovate, and removes and eliminates the interfaces that were required to connect with discrete components on radio devices. So at this point, I'll request Tim to summarize this announcement.
Okay, so a little bit about where we are with our development of technology. So in 2012, we actually created a test chip of the analog technology of these data converters. We built this on 28 nanometer, designed and validated it. We didn't productize it because it was a test chip to validate this high-speed RF ADCs and DACs. And we coupled that with our Vertex 7 class of FPGA so that the communication between the DACs and ADCs worked and was able to go out and validate our technology. So when we actually issue the press release in a few weeks, we will actually have a video of this board demonstrating the parameters and the specs for both the DAC and ADC. Again, this is the picture of the board. These are actually some screenshots from the video showing the health and robustness of the DACs and ADCs, just the analog portion for the RFSoC. So as you write your articles informing your readers, we request you have a link possibly to the video so they can see for themselves, and obviously that may create more interest. But the actual test chip is working on the same technology that we will productize, and talk about more details on the product later this year.
네.
So then finally, in summary, RF class analog technology integrated in a programmable device. So again, all programmable digital and analog is what RFSoC will be. You saw the examples of lower power, smaller footprint. Those are the two key value propositions to enable massive MIMO for 5G. Without it, we believe the rollout of 5G will take longer because you need this kind of technology, as you saw, to hit the power and footprint requirements. And then the final here, channel densities required for 5G commercial deployments. That's the fundamental driver of why we went off and built this technology to get the densities we talked about earlier.
네.
Okay, so with that, Harpinder and I could take questions. That concludes our presentation portion, and we'll answer your questions on the industry, 5G deployment, or anything about the actual technology itself.